Good morning, everybody. Welcome to day 5, or maybe day 7 if you were here for the pre-conference classes of CppCon. My name is Inigo Montoya. None of you have 6 fingers on your right hand, correct? Good, because otherwise it would get bloody. Actually, no. My name is Marshall Clow, and this is my talk, Class Template Argument Deduction. Hopefully you're all in the right room. Okay. We got to start with the obligatory about me slide, because it's always about me. So I have been a Boost author, library author for a long time, going on 20 years now. Okay, closer to 15 than 20, but getting up there. I was the lead engineer on libc++ for about 7 years. I was the library working group chair at, on the standards committee for 5 years. I was responsible. That's a great word that hides so much. I was responsible for the C++17 and C++20 releases, which means basically that my name was on the list as the chair of the working group. I didn't do all the work. I didn't even do most of the work. There were whole bunches of people who did all the work, and I got to take the credit. Yeah, no, I was not responsible. I was the library working group chair during the release process for C++17 and C++20. That's a much better way to say it. I have been programming professionally for 40 years now. Wow, it's 2022, isn't it? I got my first programming job in 1982. I've worked at a whole bunch of companies, but enough about me. The only really important thing here on this slide is if you need to get a hold of me, that's my email address there. Idio.com is easy to remember. It's idiot without the T. Okay, so we're going to talk about what is class template argument deduction. And my take on that is that class template argument deduction is another step in a progression which I'm calling let the compiler figure it out. Okay, the compiler in different releases of the C++ standard, the compiler has gotten additional facilities where you don't have to say things. If you want to think of it as of the agile programming thing, DRY, don't repeat yourself, you can see that, but this case is you're not repeating yourself, you're just not saying it. In the cases where the compiler can figure out what you mean, you don't have to say it. And that's nice, because if you don't have to say it, you can't get it wrong. Now, this doesn't mean that you can't actually specify template parameters or whatever, or for auto, you can't specify the type of a variable. And frequently you need to do that because the obvious choice is, for some reason, not the one you want. But many cases, in most cases, most might be an overstatement, but in many cases, the obvious choice is the one you want. And in which case, why say it? Because you might get it wrong. So I have a small, modest example here. We have, oh my God, we have a wall of text. We have a function here that I've written. It's clearly very important and very complicated, because I mean, look at all those angle brackets and type names and std allocator and blah, 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 blah. And nobody writes code like this, okay? This is getting no help at all from the compiler. Nothing. There's nothing that the compiler is doing for you here. I don't expect you to read this and understand it. We're going to let the compiler simplify this for us. And then you'll see just exactly what this thing does. But anyway, so this is just for reference. If you select all the stuff between the open bracket and the closed bracket, it's like 525 characters. It's a lot of text. All right. Step 1, C++98. Vector is defined like this. It has a value type, and it has a type and an allocator. And the allocator is a default template argument. It's something that if you do not specify, the compiler will fill it in for you. Okay, great. We're going to take all that text in red, because that's all a default template argument, and we're just going to rip it out. Okay? Because the compiler can fill it in for us. Hooray! This is now no longer a wall of text. Now it's a berm of text. It's something you stumble over. It's still kind of hard to read because, well, okay, because it's on a slide and the slide software has word wrapped it and blah, blah. But anyway, it's much more approachable than that. But it has the same meaning and it generates the same code, and this goes all the way back to C++ 98. You write this in C++ 98. You write this in C++ 98. It's the same thing. Okay? Next step. When you call a templated function, you don't usually have to specify the template parameters. The compiler deduces them from the types of the parameters passed to the function. And this is called template argument deduction. And for a long time, this was the only kind of template argument deduction in the standard that I can think of off the top of my head. This should probably be called function template argument deduction now to distinguish it from class template argument deduction. But that's all right. Template argument deduction. So, there, that call is defined, that has template parameters. We can just throw them out because the compiler will deduce them from, just like the compiler will deduce the allocator type of vector. And now we're starting to get somewhere. Okay, both of these things that I talked about, default parameters and function template argument deduction, are things that have existed since the dawn of time in C++. They were both present in C++ 98, 03, 11, 14, 17, 20, 23, all of them. This is not new. But now I'm going to get into stuff that's a little bit newer. In C++ 11, we got a new feature. Anybody know where I'm going with this? Auto. Type your variable. If you don't, if the compiler can figure it out, then we can let it figure it out. We take that big long pile of text that says type name std vector, type name blah, 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 iterator traits blah, 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 and just replace it with auto. Better. Now you probably have a pretty good idea what this function does. But wait, there's more. In C++ 17, we get class template argument deduction, where the compiler will fill in template arguments for classes for you. And this is really nice, because what it means for this example is that we can take all of that out. Okay? The compiler will deduce that for us. And now we're left with a very simple, straightforward function that you realize, wow, this is really lame. This is not doing anything interesting. It's making a copy of a sequence and seeing if there's a 3 in that sequence, and then returning true if it contains 3. I mean, that's a boring function, but it's way easier to understand than that. I mean, if somebody brings that to you in a code review, right? You're going to have to spend a fair amount of time puzzling it out. But if somebody brings this in a code review, you're going to say, really? Why are you doing this? You could see very quickly and easily what's going on. Okay, so now I've put CTAD, hopefully, in a historical perspective. It's something that helps you, lets the compiler help you. And you can concentrate on writing the interesting parts of your code, not boring parts like this. All right, so what does CTAD do? If you instantiate a templated class and do not provide any template arguments, that's important. Don't provide any template arguments. You can't provide some. It fills in the template arguments. It fills. I promised myself I wasn't going to use the laser pointer because it won't show up on the video, and then I went and used it already. Anyway, it fills in the template arguments. That's all it does. People are surprised by this. People who especially who like to play with things and want to bend them to their wills, they're surprised by this. There are things that it doesn't do. It doesn't let you pick the constructor that is going to get run here. All you get to do, all it does is set the types. It doesn't let you diddle with the arguments. It doesn't let you reorder the arguments or change the arguments or anything like that. It just fills in the types. This is a really powerful thing, but I've had several people come up to me. I just wanted to like reorder the parameters. You know, when I deduce this, I want the parameters to be first, third, second, fourth, or something like that. Nope, don't get to do that. Okay, what is the thrust of this besides being able to write vector v with parameters, which is really actually useful in generic code? I mean, we go back to the example, right? The compiler figured out what kind of vector we wanted. This is really nice in generic code, but what else can you do with it? It makes make functions much less necessary, much less common. You can now just write stud pair and a pair of values, and the compiler will deduce the types of the template parameters for pair there, or tuple. This is not a panacea. This does not get rid of all the calls to make pair. Maybe you want different template parameters. Maybe you don't want int and long there. Maybe you want constant and long, or int and long ref, or something like that. Then you still have to specify the parameters somehow. But for common cases, this is a lot easier to write. Just like when you're writing, generic code to work with iterators, it's a lot easier to write auto it equals da-da-da begin, as opposed to whoosh, foobity bobbity boobity boobity colon const iterator equals whatever. So I'm all for reducing typing, making code easier to understand when you get the same thing. Okay, how does CTAD work? How does it work? Oh, I should have mentioned at the beginning, if you have questions, please raise your hand and ask them as we go along. Don't save them to the end. I'd hate to have you be confused for 50 minutes when I can hopefully clear something up. If you're way, way in the back, I won't see you. I won't see you raising your hands because these lights are bright. And there are microphones up here. Anyway, so how does CTAD work? CTAD works through a function called Deduction Guides, a feature called Deduction Guides. A new feature in C++17. For function template argument deduction, you have no way of influencing what the compiler does to deduce things. Okay, the compiler deduces the function template arguments from the parameters, the types of the parameters, and you have no way to influence that. The only thing you can do is you can specify the template arguments directly. But in C++17 and later with class template argument deduction, there are two kinds of deduction guides. There are implicit deduction guides that the compiler generates, and that's really all you get for function template argument deduction. The compiler it doesn't actually use deduction guides, it just deduces them. But then there are explicit deduction guides that you write as the class author. And this influences, that's probably the best word, influences how the things get deduced. They look kind of odd. When I first looked at these, I thought these were very funny. But basically, you write template and a list of template arguments, your class name, and an argument list. This looks like a call to a constructor. And it's supposed to look like a call to a constructor. But it's just a list, the argument type list is a list of types. Your deduction guide only works on types. It's completely a compile time thing. Okay? And it says if you get these types, The deduction guide says you should deduce the concrete type of the third line there. You arrow, class, class name, template argument list. And that's a complete list there. Okay? So this is what a deduction guide looks like. Here's an example from std_vector. Almost all my examples are going to be from std_vector because everybody understands vector, and I don't have to explain what are the particulars of the class. So template type name t, type name allocator, vector, a vector that takes a t and a vector of t and alloc, deduces a vector of t and alloc. This is a deduction guide for a copy constructor or a move constructor. You wouldn't write this. The compiler will generate this for you automatically if you have a copy constructor or a move constructor, because all the information is right there for the compiler to see. In general, when you write deduction guides, you don't care about how things are passed, if they're passed by value, if they're passed by reference, if they're passed by R-value reference. One deduction guide will work for all those cases. If they're passed by pointer, well then, yes, you have to reflect that in your deduction guides. Okay. No, really, how does this work? And I'm going to say, Timur gave an excellent talk a couple years ago at C++ Now on exactly how this works. What the mechanism is for it inside the compiler. I mean, the short answer is that the compiler makes up a bunch of imaginary functions from the constructors and the deduction guides, throws them all into an overload set, and then performs function template argument deduction on the overload set. But there's a lot of weird little details. It makes up imaginary functions and then picks one. So if you want to know the nuts and bolts, watch Timur's talk. It's on YouTube. If you search Timur deductions, C++ Now, it'll probably be the first hit. Okay, any questions so far? I know it's early in the morning.
We have an online question.
Go for it.
Is it important for C++ newcomers to understand the problems that Auto and CTAD are solving?
I would use the word helpful rather than important. I mean, it's nice because if you don't understand the problems that they're solving, then you're going to write things like this, which, okay, it's valid code, it works, it's fine, but it's much harder to write and much harder to understand than that, okay? Hopefully that answers your question. All right. Okay, we're going to look at vector, because everybody's happy with vector. What does vector look like? What is the definition of vector? It looks like this. It has two template parameters, and one of them is defaulted. The first one is the value type. It's the thing that's being stored in the vector. The second one is the allocator. Okay. When I'm designing deduction guides for a class, first thing I do is I list all the constructors, because it kind of gives me an idea. Okay, what am I working with? The compiler is going to try to generate implicit guides from as many of the constructors it can. And frankly, the way the deduction guide works is the class template argument deduction fills in the template parameter types and non-type parameters, and then it's out of the way, it's done, and then the compiler tries to match a constructor to the vector type parameters and the parameters that you pass to the constructor. And sometimes that doesn't work. Sometimes you get a deduction and then the compiler tries to actually instantiate the call to the constructor, and that doesn't work. So I usually start looking at the constructors. These are the constructors to vector. I'd have, some of them vector has a constructor that takes a defaulted parameter, an allocator, for example, that has It has a default value of the default constructed allocator. In this case, I've split them out to make them easier to talk about. Over here where it says iter : value type, really that's shorthand for iterator traits, decal type, iter : value type. It's basically you don't read the value type out of an iterator, you wash it through iterator traits because, for example, pointers are valid iterators, they don't have a nested value type. Anyway, this is all of them.
You have a question?
Yes.
Is there no requires clause or room for concepts in the deduction guide syntax?
Is there no requires clause or room for concepts? So you can put constraints on deduction guides. You can use concepts there. I don't know if you can actually use a requires in there. I would assume you could. Let me rephrase that. I have never used a requires clause in a deduction guide. Because I've been doing a lot of stuff in C++17, I use enable if. I know of no reason that wouldn't work. Okay, I know you can use concepts, but I have never used requires whatever. Okay, anyway. The first one of these, the default constructor for vector. There's nothing for CTAD to work on here. If you just say vector v semicolon, the class template argument deduction, the compiler is going to build the list of guides, it's going to look at them, it's going to do its magic on these, it's going to, and it's going to say, I have no idea what the template arguments for a vector should be. And it will fail to compile. You'll get an error message in Clang, you'll get it that says, no matching deduction guide or constructor for blah, 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 blah. Okay? There's just nothing there. There's not enough information there for the deduction guides to do anything for you. You're gonna have to say vector int or vector long or vector fooby, comma, my allocator fooby or something like that. The next two, vector just takes an allocator, vector takes a size t and an allocator. The people who defined the deduction guides for the standard containers chose not to write deduction guides for these cases. You could, in fact, write a deduction guide for this case. You could look inside the allocator, use allocator traits to find out what the value type of the allocator is, and that would be the value type of the vector. But since that's not really, strictly speaking, a requirement, it's not a requirement that the allocator passed to the constructor of vector matches the value type of the allocator matches the value type of the vector. We chose to leave that off. You can, basically, if you read the standard, it says that the allocator, you have to be able to match the value type of the container with the value type of allocator traits rebind blah, 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 with the allocator that's passed in. libstd C++, for example, will just mechanically rebind the allocator. You can pass it whatever, it will rebind it to match the value type of what you have. libc++, on the other hand, will complain if the value types don't match. So the standard library chooses not to deduce in that case. Okay? The next four are copy constructor, move constructor, copy constructor with allocator, move constructor with allocator. Those are easy. The compiler will generate those themselves because it comes out to be the same thing as you're copying or moving. Okay, the next couple, where you take a size type and a value type, value type, allocator. There is enough information there to deduce value type and allocator type, which is great. And in fact, the compiler can do that. The implicit guides are good enough there. Yes, who has a question? There, Fedor?
If you give it the allocator in the copy constructor, it ignores the allocator, the type of the allocator you're trying to give it, and reuses the one from the source, right? That's what you're saying.
In the so the question is, if I've got this right, in the copy and move constructors,
like the 4th and 7th line, yeah.
Yeah, the ones that take an allocator,
yeah.
It will in fact, yeah, use the type of the allocator that is in the source vector that you're copying or moving from. And the reason, I mean, you think about that, right? You're making a copy of the vector, right? You can't, it's not obvious that you can convert from one allocator type to another. Rebind might work depending. So when you're calling a effectively copy constructor, you expect to get the same type.
So what does it do with the allocator?
What does it do with the allocator given? It passes it to the constructor. And if the constructor cannot actually handle it, you get a syntax error. You get a compile time syntax error. Nevin.
Are these all compiler generated?
The ones I've talked about already so far, yes, are compiler generated. Anybody else? Okay. Let's skip down to the last two. Initializer list. Initializer list, if you give a vector initializer list t, you get a vector of t, initializer list alloc, you get a vector and an alloc. Again, the compiler can generate these because all the information is right there. The compiler knows about. The compiler knows about initializer list. Okay, an initializer list is a language thing. The compiler knows that if I give an initializer list t, it knows what type of the initializer list is. And so this is another one that the compiler can generate. And all we've got left is those two in the middle. And in fact, vector has only one explicit deduction guide. One deduction guide that's not generated by the compiler. Okay, and this is because the compiler doesn't know iterators. Okay, the compiler cannot generate something from iterator, alloc, because the compiler doesn't know iterators. Iterators are this big fertile field, right? Pointers are iterators. There are iterators in the standard library. There are iterators in Boost. There are iterators in your code. There are iterators in your code. And they all look different, right? The compiler, yeah, we all funnel them through iterator traits, but the compiler doesn't know iterator traits. And we don't really want to teach the compiler about it. So let's look at this. This says, right, here's a deduction guide that has 3 template parameters. And it says that if you see a call to vector with iterator, allocator, the allocator has a default value, but it doesn't have to use that. If somebody provides it, then it takes that other type. You deduce a vector of value type and allocator, and the value type is in the template list up here. Value type was type name, iterator traits, iterator colon value type. What happens if you pass like int alloc? The instantiation of iterator traits int succeeds because iterator traits is SFINAE friendly. It generates an empty struct. You try to look at the value type. It says, yeah, I got nothing like that. This template fails to, I don't know what the word is. Compile. It's not instantiate because, what? Substitution failure. Substitution fails, and this drops out of the overload set that the compiler is building, and then so this deduction guide is not considered for filling in the types. Okay. I'm sorry. Somebody have a question over here. Over here. Stop.
You're using the same identifier alloc twice. Is that correct? You have,
yes.
The deduction, the default allocator is allocator value type, but you can also specify an allocator.
Yes.
Which I would assume would have a different name, no? Alloc equals, oh, I see what you're saying. Yeah, that makes sense.
The line that ends with the arrow, the parameters there are all types.
Yeah,
they're all types. Yeah, deduction guides do not deal with values ever. I mean, I have tried to figure out if you could do something in a deduction guide with a non-type template parameter, and I haven't come up with anything useful. Go ahead.
I actually have a question on that. So alloc already has the default type. Why does it need default value?
Okay, and why? The question is, alloc already has a default.
You just said that values don't matter, like as in the deduction guide.
And the question is, why alloc already has a default type? Why does it have a default value? So on the line that the last of the template argument list, it has a alloc equals allocator value type. So if nobody specifies what the type of alloc is, you get that. And then on the one that ends with the arrow, it says alloc equals alloc default constructed alloc. And the reason for that is because this, this deduction guide is covering for two constructors. It's covering for the one that takes iter and iter alloc. So if you just pass two iterators, you get this still matches the type list of the parameters. And so that's how this matches. Okay?
Question.
Yes.
Are we paying in compile time for these improvements to ergonomics with CTAD and similar features?
Are we paying in compile time for these, for CTAD and things like that? Absolutely. How much is it? I have not been able to measure it, so I believe it's not significant. But absolutely, this is more work for the compiler. Okay? Yes?
Is there a way to get, is there a standard way to get the compilers to output what deduction guides it's going to imply?
So the question is there a standard way to get the compilers to output the what deduction guides it's going to imply? No. And I have slides about that coming up. Okay. Let's talk about writing deduction guides for your classes. Actually, any more questions about vector? Okay? Ben's going to ask a question. Yes, right here while Ben's getting to the front.
This is kind of an odd thing because there's no keyword class in front of vector, so this is not a declaration of a vector class template, which means that that simple vector has to be defined in some scope. Where do I find this thing written?
Okay, so the comment is there's no word class before vector on the next to the last line. And so he's asking, where do we find these things and how does it know to match it up with the class template vector? Usually these are defined in the same header file as your class. So this is actually taken right out of vector. And in particular, I tend to put them just immediately after the closed squiggly brace of I've just finished defining vector. And then I put the template deduction guides, the explicit deduction guides, and then any out-of-line definitions of functions. So they tend to be right next to the class. Ben.
Is it undefined behavior if user code provides deduction guides for standard templates?
Wow, what a great question. Is it undefined behavior if user code provides a deduction guide for a standard template? I would expect that to be the case. It might not be the case if you were trying to provide a deduction for, say, vector with one of your types, but that's kind of a stretch. I think the answer is you want to write deduction guides for your classes, not for other people's classes. Okay, it would not surprise. Nevin has said he thinks there's blanket wording that says you can't do that. It would not surprise me to learn that. Okay, any more questions? No, great. All right, deduction guides for your classes. How do you write deduction guides for your classes? It's an iterative process. Do you have your hand up? Okay. Figure out what deductions you would like to have. Okay? Write a bunch of tests. I mean, usually what I start with is what I showed you before with this. I list all the constructors and think about each constructor. But that's not necessary. That just works for me. Write tests. Run the tests. you might be very pleasantly surprised to see that most of the things you want to have deduced already are deduced because the compiler has generated implicit deduction guides. Okay? Some will succeed, some will fail. For the ones that are failing, you have to write deduction guides. Okay? Add deduction guides for those cases, and repeat. If your test environment supports it, I strongly suggest writing negative tests. Write a bunch of tests that you expect to fail and verify that they fail. Misdeductions, unfortunate deductions, wrong deductions can really, really confuse your users. So, write compile fail tests if you can. Sometimes you have to, even though it doesn't say enable if or requires or anything, this is constrained to only work with iterators because substitution failure on iterator traits. You will probably want to constrain your deduction guides at some point. Anyway, for the ones that fail, add deduction guides for the cases you think of, and repeat until you're happy. Okay? But lots of tests are great. When you're writing deduction guides for containers, you very quickly run into existential questions. Yes?
Is there a way to disable deductions that the compiler normally would make automatically?
Hang on to that question. Is there a way to disable deduction guides for the compiler that compiler implicitly generates? No, but. Hang on to that question. So, when you write deduction guides for containers, you quickly run into two existential questions. What is an iterator and what is an allocator? Because you're looking at go back to that list of vector constructors, and there's iterators and there's allocators all through there, and you don't want to deduce things. You don't want to say, oh, look, I have this 3-item thing where the third parameter is an int, and I don't want it to deduce that this int is my allocator, because that's just not going to work. I mean, you can deduce that, and then when it tries to call the constructor will try to form allocator traits int : value type, or allocator traits rebind int to whatever, and it's like, no, your compilation will blow up. So you're going to have to think about what it is that makes an iterator, what it makes an allocator. Iterators are fairly easy, right? We have iterator traits. Allocators are hard. We have allocator traits, but they're not. You can customize allocator. The standard has some kind of minimal guidance for this. Okay, it says that integral types are not allogators. Integral types are not iterators. In particular, if you read the fine print down in the container requirements, there's some allocator requirements, and it comes down to it needs to have a nested value type. This is what the standard says is your minimal tests. It needs to have a value type. And it needs to have a member named allocate that can be called with a single parameter of type size t. You can do better than that. You can do a lot better than that, but that's kind of a minimal set of constraints. Every standard library, if you go digging around, has a type trait called is allocator or something like that, that basically implements something very similar to that so that they can use it in their deduction guides. You probably have to implement one of your own. Anyway, okay. Pitfalls of writing your own deduction guides. Okay, what happened? How are we doing time? 20 minutes. Whew. We're gonna have to keep moving up a little faster. Debugging. Debugging is hard. This all happens inside the compiler. You don't get any views into this. You don't get to see what happens. Yuck. Anyway, this is the best tool I have. I have a macro called assertSameType. I use it in my tests a lot. Okay? You get to see what's happened. Basically, when your stuff misbehaves, you get to look at the smoking remains of your compilation and see what's going on. Static assert, same type of the two things, and tells you. And you try it here. Here we go. Here's an example. Int star p, vector pp, assert that vector is the same as vector is long. I mean, okay, we know it's not going to be vector of long. It should be vector of int, because that's an int pointer. But for the purposes of this demonstration, I'm going to say I expected it to deduce vector of long, and I get blah, 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 static assert failed due to requirement, standard is same, stud vector int, allocator int, stud vector longs, allocator long. So the first one, decal type v, that's the first one, vector long's the second one. It shows you what was deduced and what you thought should have been deduced. This is really handy for figuring out you've gone off the rails. It's not that handy for figuring out why you've gotten off the rails, but it tells you, no, this didn't work. Okay? Note that it doesn't matter what the value of p is, right? The value of p, the only thing that's important about p is the type. You can stick this code in a test in a function in your test driver and never call it. That's fine. The only important thing is, did it get compiled? Right? This is not a runtime test. It's a compile time test. I mean, your compiler will probably complain at you that you're using p uninitialized. Fine, you can set it to null putter or something. But the value of p is irrelevant. Okay? People happy with this? Another pitfall is sometimes you have to know when not to deduce. Okay? SharedPointer, for example, has no deduction guides from a raw pointer, and this is why. Consider two pointers, 1 and 2. One you call new int, one you call new int 5. Now you try to create shared pointers from 1 and 2. What should the types of p1 and p2 be? I mean, the type of p1 should be shared pointer int. The type of p2 should be shared pointer int bracket. Okay, because otherwise when they destroy self, the first one you want it to call delete on the data, and the other one you want it to call delete brackets. But the types of 1 and 2 are the same. They're just pointers to int. Okay? And so the deduction guide doesn't have that information, doesn't know that those are really, one's a pointer to an array of int, one's a pointer to, to a sequence of ints, one's a pointer to a single int. And so SharedPointer has the people who designed these said SharedPointer cannot deduce from a raw pointer because it can't do the right thing all the time. And the wrong thing would lead to undefined behavior down the road in your code, and we don't want to do that. SharedPointer does have deduction guides that let you create one from a weak pointer, from a unique pointer, and those work great because all the type information is there. Okay, now who was the one who asked about can you actually edit the, it was you, edit the deduction guides that are automatically generated? The answer is no, you can't. The compiler just generates them. Just a sec. But before C++17, string had a constructor that looked like this: ties type, character type, and an allocator. After C++17, this was effectively a template with an enable if, because we added a constraints. Allocator is a type that qualifies as an allocator. And the reason was because the implicit deduction guide that was generated from this constructor was very, very greedy, was matching lots of things. I mean, string has a bazillion constructors. And it has constructors like size type, char type, and count or something like that. I don't remember. But it was matching lots of constructor parameter types that weren't this, and then it would blow up because it would try to instantiate, allocator traits : int or something like that, or unsigned long or something like that. And so the way that this was fixed was to add a constraint to this and a few other constructors of standard string, which effectively turned them into templates. But basically, that constraint was propagated to the implicitly generated deduction guide. and now this works correctly. For people who want to go look up the gory details, this was LWG bug number 3076. But it was done in, if you read the standard for this and probably 4 or 5 other ones, it says, constraints, allocator is a type that qualifies as an allocator, which refers back to that wishy-washy, hand-wavy thing I talked about earlier where it has a nested value type and a member function named allocate that you can call like this. It says you have to be at least that good. Did you have your hand up? SharedPointer has a, I believe they just didn't define it. The question is, how did they disable it? That's a good question because why was it not implicitly generated? That's a really good question. I don't know. Okay, Pablo says it would be ambiguous because SharedPointer has more than one. The two different instantiations of SharedPointers would have the same constructor, and the compiler would be unable to tell. That's a reasonable explanation. Okay, that the compiler would say, I have SharedPointer int and SharedPointer int brackets. I have 2 of these. They both take a single pointer. I can't decide which one to instantiate in this case. I never thought about it. That's a reasonable explanation. Okay. So this is a pitfall. This is. I remember who asked about editing implicit deduction guides. This is kind of the only tool you have. You can add constraints to your constructors, and those constraints will be reflected in your in the implicit deduction guides. But there are really very few knobs you have for the implicit deduction guides. Okay, post C++17 work. There were 3 features added to for deduction guides for CTAD after C++17. Some of these people thought of before C++17 and then just couldn't get them in time. First one was CTAD for alias templates. If you define an alias template in C++17, you can't do this because the deduction guides do not come along with the alias template. In C++20, they do. You cannot define deduction guides for an alias template because by using an alias template, you say, I want this to behave exactly like that thing over there. And if you could define deduction guides, they wouldn't behave the same. Okay? So this was a really obvious thing, and I'm glad it's there because it makes things much easier, makes alias templates much more friendly. Another one for aggregates. You can define now, if you define an aggregate, you get you get implicit deduction guides. An aggregate, maybe the definition of aggregate, everything's public and so on. But this will work just fine in C++20, not in C++17. In C++17, it'll say missing template parameters for PT. Okay. And the third one of these that I don't have a slide for was CTAD for inherited constructors. If you inherit from some type and then you say using base type : base type and inherit all the constructors, you get to inherit the deduction guides as well. This is not something that you see that often, people inheriting all the constructors, but when you do, it's really nice to have the deduction guides come along for the ride. And then in that case, you can actually add your own deduction guides as well, because it's your class. It's not an alias for some other class. Okay. Summary. CTAD is a really nice tool, reduces boilerplates, especially in generic code. Writing a deduction guide is not really very difficult. Getting a set of deduction guides correct, the tools are kind of limited. I suggest writing lots of tests. The good news is the tests are are easy to write. They're very straightforward. You say, create a variable like this, look at what the type is. That's really what you got. Sometimes you have to scratch your head and think about what's going on, and make sure that, try to figure out which deduction guide fired. If you want to know the nuts and bolts, again, watch Timur's talk. Timur will walk you through what goes on inside the compiler, because he has had to write a front end to do all this. So he's very up on it. Failure to deduce is not a disaster. It's not a horrible thing that this doesn't work. You know, if you can't give an answer that's helpful to your users, consider not giving an answer. Okay? They can type angle bracket int, close angle bracket, or angle bracket int, open brace, close brace, or square braces. It's not a disaster. It's an inconvenience. Okay? Misdiagnosis, misdeductions is a bigger problem. The good news is a misdiagnosis, if you misdeduce, chances are pretty good that it will fail to compile. You know, that when you deduce the template argument types, the compiler says okay, and picks a constructor, and calls it with the parameters, and it fails to compile because, you know, you've passed an int as an allocator or something like that. But you want to minimize the misdeductions. Failure to deduce, I mean, the good news is most of the times if you misdeduce something, you get a compile error. And then the user has to specify the template parameters manually. Okay. That's not a terrible thing. Remember that when you are designing a class, when you're writing the constructors for your class, you are writing the implicitly generated deduction guides, and keep that in mind. Think about that. Think about, you know, vector. I don't think that anybody had in mind in 1998 class template argument deduction, but this is a set of constructors that is actually not unreasonable. Strings are unreasonable. Strings required a lot of work to make it so that the deduction guides were not just really unhelpful, misdeducing things or getting ambiguity records, getting ambiguity errors, excuse me. When, you know, of these, what, 15, 3, 6, 9, 13 constructors, we had to write one deduction guide, one guide to cover 2 constructors. The implicit guides did the right thing in the other 9 cases. This is great. String was not so good. But so keep in mind when you're writing your class that you are writing deduction guides. You are writing things for the compiler to generate. Ambiguity is probably the hardest thing to solve when you're writing your own deduction guides. You write the deduction guides, and you'll run your tests, and the test will fail to compile with it says, such and such is ambiguous, and you look and it will, most compilers will tell you, it's like, I'm looking at this deduction guide, and I'm looking at this deduction guide. Sometimes it'll say, I'm looking at this deduction guide and a built-in deduction guide, and hopefully it will tell you, the details of the built-in deduction guide. That's the thing that when I was doing this for a bunch of classes was the hardest thing to debug. It's like, you stare at the message and look at the 2 guides and try to figure out why they both fired and how you can make it so neither of them, one of them fires or something like that. Anyway, but it's a nice feature, especially when you're writing generic code and you don't have to type everything out. Again, if you want to do, if you really did want a vector of longs here from, in this case, you have to write vector long. That's fine, okay? Just like, when you're doing stuff with iterators, you don't want the thing that auto gives you, you have to write it yourself. That's fine. But in the cases, which is the common case, where everything you're doing is very straightforward, why write something that the compiler already knows? Okay. And that's the end. And we have 5 minutes left for questions. Yes.
As someone who didn't work to try to standardize this, it seems like there's a really big bifurcation between CTAD and let's call it FTAD.
Okay.
Things like I can specify the first of 2 parameters for FTAD, but not for CTAD. Can you speak to why that is? Why can't I just write, I want an array of strings, but the compiler can work out how many strings based on the initializer list?
No, I can't actually think of why they did it that way. I read the library papers for CTAD. I haven't, it's been like 4 years since I read the core papers for CTAD. There may be some justification in that, but it's very clear that no, it's the only way that CTAD kicks in is if you write something with no template parameters at all. And I don't know if that was considered and rejected or if it was just said, yeah, no, we're just going to go with the simple stuff.
Thanks.
Okay. Over here?
For your macro that you're using to test the types, would it be possible to like token paste and capture some of the type information so that it would be outputted? So it's like, this was what was deduced, or?
That's, so the question is it possible to token paste some of this stuff? That's what this does. Okay. If you look at where this fails, okay. It prints the types that I've highlighted in brown. It says failed is same, vector int, vector long. Those are the 2 types that I'm comparing.
Sorry, I missed it.
No problem. Anything online? Nope, guess not. Okay.
So you've shown template deduction for constructors. Can you use template deduction for member functions?
So the question is, I've shown template deduction for constructors. Can you use them for member functions? I believe that falls under function template argument deduction. And I think you can do that all the way back to 98. But I haven't tried it off the top of my head.
Thank you.
So, yes?
You mentioned when testing these that it's helpful to have a test framework that can test that a chunk of code fails to compile. Do you have an example of such a framework for libc++ perhaps?
Do I have an example of such a framework? Yes, the test framework which we use in libc++ has compile-fail tests. And in fact, because most of the time we're working with Clang, it not only does compile-fail tests, but it checks the error, captures the error messages, and looks for the right kind of failure. This is really hard to do if you're using several compilers, right? And we disable the check for the right kind of failure if you're running it with MSVC or with GCC or ICC or XLC or whatever. But it's really easy to write code that fails to compile, and then you just look, oh, it failed to compile. And then sometimes later you go look at it, oh, it's failing to compile for the wrong reason. And so, I mean, the testing framework that libc++ has is a homegrown framework. And the reason for that is not because Howard Hennant, who started it, and I who kept going with it, and Louis and others who are doing it now. We hate other test frameworks. That's not it. But all the C++ test frameworks that I have looked at make heavy use of the standard library, and they should. But when you're trying to test the standard library, you may not be getting good answers out. You may not be getting, if you're trying to run tests in vector and you're collecting the results in a vector, if you have a problem, it's not going to give you reliable results. And so we don't use any of the popular test frameworks there. It's a special case, okay? I don't know if any of the, well, the boost test framework definitely has a failed as expected setting. I just don't know if it has a compile failed expected. I believe it does, but it certainly doesn't check the error messages to say this failed for the right reason. That's a really helpful feature. If you're concentrating on one compiler, you can get away with that. So, all right, Nevin, we'll just take 2 more questions because the thing just clicked over and it says it's 10
This
o'clock.
is more a comment. There is another hammer for disabling implicit deduction guides. They come from the primary template. So if you don't have a primary template, you can't get the deduction guides.
Okay, yeah, I think I mentioned, I alluded to that the deduction guide set gets built up from the implicit guides, the explicit guides, and some other stuff that I didn't really want to go into. Okay. Okay, comes from the primary template. Thank you. Yes.
How does the, deduction work if you also have non-type template parameters? Well,
that's a really good question. If you have non-type template parameters, you can fill them in. You're going to have to do something about that. You're going to have to figure out, because all that the deduction guide is going to look at is the types of the parameters that are passed to the constructor. So
you make standard array.
you make standard. You can for Nevin said you can have something for std array. Std array will deduce from the initializer list. The constructor that takes an initializer list will look at the size of the initializer list and deduce the size of the array. But in general, the deduction guide is going to have to invent the non-type template parameters.
Okay. But the rule of you have to supply all the parameters, or it can only deduce all the parameters applies even for non-types. So you can't, for example, have a small container with a templated size and have it deduce the type of the array that you're writing, but only specify the size?
I'd have to think about that one. I'm not sure. But yeah, a deduction guide does not actually have to say it doesn't have to provide all the template parameters. It can leave off the ones that have default values. But the ones that are not default values, no, it has to provide all of those. And so maybe that's a partial answer to your question.
Okay. I might have to experiment with it.
All right. Thank you. Thank you very much.